we are going to take a look at the Haasoscope Pro. So on the front, you've got the basics. You've got two inputs that can be either 50 ohms or 1 mega ohm. We've got a couple USB connections there just to give 5 volts to some accessories. This is great for plugging in active probes, which we'll need to unlock the full bandwidth of this thing. This can go up to 2 gigahertz of bandwidth, maybe even a little more. So yeah, a whole new class of scope compared to what a lot of us are dealing with these days. That's really what makes it exciting. One thing the FPGA is doing to be able to, while it's processing all of this data coming in from the ADC, is that it can actually, it's got a 12-bit ADC, right? So and that's coming in 3.2 gigasamples per second. And so it's a lot of information, and if it's coming in fast here, and we're running fast, then okay, there's not much we can do. We just have to kind of store it all and display what we see. But there is noise, right? So so what can we do to help get rid of that noise? Well, a nice trick is averaging, right? So if you want to go slower, you know, this noise here, clearly we're triggering on something. You can see like a little blip. So, you know, it's not all just totally random. Like maybe that's a little bit of RF or a little bit of power or something. You know, I have it out of the case right now, so so we might be getting some RF in there, and I don't have anything on the input, so I might be getting something sneaking into the input. But anyways, we have a little bit of noise, so how do we get rid of that? Well, if we're going slower, right now we have, well, almost a millivolt or over a millivolt of noise. But if we want to go slower, right, we can start averaging out those samples. Meaning the FPGA is taking sample 1 and sample 2 and sample 3, maybe 8 of them, right? So right now we're downsampling by a factor of 2 to the 3. So we're going 8 times slower. But of course, the FPGA is still getting all of the full data rate of information. The ADC is still running at 3.2 gigasamples per second. But we can take all that data and just average together 8 of those samples and then spit out the average result. So it's the FPGA is doing all of that in real time, and you can see how the noise just, you know, disappears. So by the time you get to 2 to the 8 downsampling, you're averaging 256 samples, and so you're reducing the noise, you know, by almost a factor of 10. So, you know, here we're down to, you know, just 140 millivolts of noise. Another thing you can do while we have this little bit of noise to look at is we can look at an FFT. So you can click this button here, and we start doing a real-time FFT. So this is a nice feature of Python. It's really flexible. You can analyze the data using the full power of all the Python packages and libraries when you have the data coming into this Python interface. So yeah, there's our FFT. You know, if we go a little slower, we can go to lower frequencies and start to see maybe what this noise is. Getting down to hundreds of megahertz. You know, we were up above a gigahertz before, and we're still going down. We have 40,000 samples here in each of these events, so it's quite a bit of data. We get a pretty good resolution on our FFT.